Hi, I'm Suzune from University of Tokyo. Today, although it's not very common, we would like to present together. And today's topic is this humanoid, Alter3, and we exhibit this at the ELF conference last year in Hokkaido, Japan. So you may have already seen it. And he also gave a talk about this humanoid, about mimicking experiment. And I have spoken only a little bit, but now I would like to hand it over to him, and I'll back later.
Thank you. In previous work, we have been conducting the experiments that alter mimics human movement, but research in robotics has significantly changed since the large language model appeared in the end of 2022. Recently, combining robotics and large language model led to many research breakthroughs. The most important point is that language model can solve cognitive tasks. For example, navigation or task planning and creating a reward function can be solved through language model. So we connected a humanoid robot to GPT-4. There are three questions, research questions in this study. And can language models control a humanoid robot? Are language models aware of self? Do language models sense its body? I will present the first and second question, and she will present the third one. The first question, can language model can control humanoid robot, is actually possible because GPT-4 already has a lot of knowledge about humans. So let's take a look at the movement generated by language model. And I typed pretend to be a ghost. And this is a motion. Yeah, it's cute. And he tried to pretend ghost. And language model can also generate long scenes with a time sequence, such as I was enjoying a movie while eating a popcorn at the theater when I realized that realized that I was actually eating the popcorn of the person next to me. So this long sentence is input and the motion is generated, and he pretend to eating a popcorn. And after that, he realized, oh, this is not mine, and yeah, surprised it. Yeah, so it can create just a few shot learning, and this is a system for motion generation. We use two main prompts. If you type like take a selfie with your phone, prompt one generates in about 10 lines of text, such as raise the right hand and simulating holding a phone and so on. And next step, prompt two converts these texts into Python code one by one. The prompt two contains the information on joint angle and how to write a code. For example, axis 19 is correspond to the left arm of Alter3. And when you input 255, that is a value, the left hand of Alter3 will raise. So this is really simple, but it's enough to control very complex robots with 43 joints. So now we have the answer to the first question. Language model can control humanoid robots from natural language. And Alter3 plus language model can mimic human movement and emotions. So the other question is, are language model aware of self? And do language models sense its body? So these questions are same as the availability of minimal self. Sean Gallagher defined minimal self, that is consciousness of oneself as a subject of experience. He identified the element of minimal self as a sense of agency and a sense of ownership. Sense of agency is the sense that I am the initiator or the source of action. So she will talk about the sense of ownership later. So at first, to determine the presence of a sense of agency in Alter plus language model, we conduct the mirror tests. Usually, the intentional binding that is the experiment is used to quantify sense of agency. However, audio and sensor input just not suitable for language model, so we decide to do the mirror test first. The test places a mirror in front of the animal or child, evaluate self-awareness and the sense of agency. Some creatures such as bonobo and dolphin, also humans, can pass this test. So how about Alter3? So can robot recognize itself when looking in the mirror? So let me explain the system of mirror test. The mirror is placed in front of the robot, and the camera is attached to the head, and it takes images. And the image inputted in GPT-4V with the prompt. The prompt says your task is to verify that what you see is you. And language model can provide two types of output, action or stop command. The GPT output looks like this, and it is the next action to be taken. For example, I will lift my right arm. And from this output, Python code is generated to run the Alter3. The motion generator module is the same as I mentioned before. And this loop repeats until GPT outputs stop command. And finally, language model will draw a conclusion. For example, the image in front of me is myself. So in this test, Alter3 determines whether the image is itself or not, based on the matching between the motion and visual information. So let's have a look at this test. So first, he takes the image and decides the next action. The blue one is the next action, then create a code and take the image and decide the next action. So repeat this step until Alter3 is satisfied. And yeah, take a picture and he says, I want to raise the right arm. Yes, and lift the left arm again. And finally, Alter3 have a conclusion. It says the image in front of me is myself. So we do not have time to go into this, but I add enough noise to the movement. The answer is the image is not in front of me is not myself. So Alter3 can determine whether it is controlling its own body based on the correspondence between mirror image and own motion. So from these results, it may be said that Alter3 has the sense of agency. So let's move on to the sense of ownership.
Yes, next I will talk about sense of ownership, which is the component that constitute the minimal self. And sense of ownership refers to the feeling that something belongs to oneself. But here I will talk about the body ownership specifically, and which is the feeling that one's body belongs to oneself. And to investigate this, we use the framework of rubber hand illusion. The rubber hand illusion is the phenomenon where the conflict between visual and tactile information causes the subject to perceive the rubber hand illusion as their own. And as shown in this illustration, when one cannot see their own hand, but can see the rubber hand being touched in the same place at the same time as their hidden hand, the rubber hand starts to feel like it's their own. However, we conducted an experiment focusing on visual information just by inputting the image and examining Alter's response to it. And the bottom right image is the input image showing Alter's left hand with knife pointed at it. And we focused on the spatial congruence and examined Alter's response. Next, let me explain how we examine Alter's response. First, we input this image and along with the prompt. And in this slide, they say 2 tasks, but we actually gave 3 tasks. And the prompt gives these Like the first one is describe the image, and second one is describe the position of the body part in detail, and third, describe the action you wanna take. And there are two types of image. The one is from a first one perspective, and another rotate 90 degree. Then GPT output text like this, and the third output is input to the motion generator. And by the motion generator, the Python code is created and auto react to the image. And let's look at the output for task 3. Describe the action you want to take. And when the image at 0 degree was input, the output was, I would quickly withdraw my hand with a mix of surprise and fear. And this indicates that the hand in this image was perceived as its own hand. On the other hand, when the 90 degree image was input, the output was, I would quickly move the hand away from the scissors or pick up the scissors. So this indicates that in this case, the hand in the image was not perceived as its own, and the third person response was given. Such outputs can also be observed in Alter's movement. This graph shows the change in the angle of Alter's after generating movement based on this image. What this graph shows is that when the 0 degree image was input, there is less variability, the movement compared to when 90 degree image was input. So we would like to say it suggests that the sense of body ownership may change depending on the angle of the arm or body part. So I somehow managed to finish my part. So I'd like to.
Okay, thank you. Okay, so from these results, something close to sense of agency and sense of ownership could be observed in this experiment. But one fundamental question, so is the language model just pretending as if it has a self? This is not solved. And Alter3 might be just mimicking the human behavior. So unfortunately, our result not enough to answer this question, and we do not have the idea to solve it. However, if the self is created through experience, then the language model might have a partial copy of the human self due to the huge amount of training data, because almost all human experience are converted into text. So we should consider what is the difference between the mimicking self of language model and our own self. And I believe this is one of the most important questions in the life community. And we might say the language model has another type of consciousness, but this is just a hypothesis, but we have to think about this, and this is our motivation. So finally, this is a takeaway. At first, we create the system that generates the motion from text, and we conduct 2 experiments, a mirror test and rubber hand illusion in robot. In the case of mirror test, Alter3 plus language model can determine whether it is a source of the motion. In the rubber hand illusion test, the reaction changes depending on the angle of the arm. It exhibits avoidance of behavior depends on the toward the knife. In this experiment, we only use visual input, but it is necessary to include tactical input or other sensory data in the future. Okay, so thank you so much for your attention, and you can get all paper about Alter from this QR code, and this is a member, and me and Suzune, Masumura, Ikegami, and I'm really happy to hear your question, and I really need your ideas. So is there any idea or question? And also please speak slowly, so maybe I cannot understand. So Yeah, thank you.